Hello students, in the previous session we have started the differentiability. In that we have discussed how we can differentiate a function at a point, and also we have saw an important theorem that every differentiable function is continuous, but the converse is not true. That means every continuous function need not be differentiable. Okay? And we have given a counter example by taking f of x is equal to mod x, right. And then in this session we are going to discuss about the differentiation of composition function, and also we are going to discuss the differentiation of implicit functions. Okay. So, the differentiation of composite function we call it as a chain rule. Okay. See that here now, chain rule. Suppose f is a real valued function which is composition of two functions u and v. Okay. So, that means f is equal to v composition u. Okay. In this place what I do is, now here suppose I take t is equal to u of x. Suppose when I take t is equal to u of x, and if both dt by dx, now t is in terms of x it is. That means whenever x changes, automatically t changes. If both dt by dx and dv by dt, because now when you take in this u as a t, it becomes v of t. So, that is why dv by dt. If both dt by dx and dv by dt exist, we have df by dx is equal to dv by dt into dt by dx. It is a composition of two functions, it is formula. We call it as a chain rule. df by dx is equal to dv by dt into dt by dx. And suppose it is a composition of three functions u, v and w. Suppose f is a real valued function which is a composite of three functions u, v and w. Then it will be like this, f is equal to w composition u, composition v. Now we take v of x as something t, okay, and then u of t, when it become v is okay, when you become v is a t, then it become u of t, and it is taken as yes. Okay, then in that case df by dx, how we can give d of w composition u by dt into dt by dx, and again by previous composition derivative formula, chain rule, we can apply dw by ds into ds by dt into dt by dx. So, because whenever you take like this function, it is changing like this. See that here, I will explain this one. F is equal to w composition u, composition v, okay, fx. It is nothing but w composition u of v of x, then w composition of u of v of x. Okay. So, v of x is t, right, then it become like u of t, and then u of t is s, w of s. That is why we are writing dw by ds, dw by ds into, next s means u of t, right. So, ds by dt, and then again t is a function of x, right, t is a function of x, that is why dt by dx. In this way we are going to use the differentiation of composite functions. I will explain it to you. Even if you not remember this formula also, we can do the problems. I will give you a simplified form for you how to work it out. Suppose you are having a function sine of x square. You need to find out the differentiation of this sine of x square. You need to find out d by dx of sine of x square. Okay. Just in a simple way I will tell you, you see that the outer function always when you are differentiating, just you assume whatever it is present inside is something x, you feel like x. Okay. So, what is the d by dx of sine x? In previous sessions we have studied. So, what is the d by dx of sine x? d by dx of sine x is cos x, right. So, cos of x square but we assumed as x and we worked out, but it is not really x, right? So that's why we consider its derivative d by dx of x square. Its rate of change need to be considered. So cos x square into differentiation of x square is 2x. So 2x cos of x square. Like this you can work it out. But if you want to work like this, I will tell you that also. See that here fx is equal to sine of x square this is. We can write this is a composition of two functions. Suppose I take this is g of h of x, g of h of x it is, where g of x is sin x and h of x is equal to x square suppose. Okay. So g of x is sin x, h of x is x square. When I take the composition of these two, g of h of x, what I get? Sine of h of x, right? So sine of x square this is, right? It's composition of two functions. Whenever you want to work it out by using this formula, then we have to take this h of x as something t it is, right? So x square we take it as a t. T is equal to x square. Then you need to differentiate with respect to x only, compulsory. D by dx of t is equal to d by dx of x square. So what do you get here? D by dx of x power n, formula you know it, n into x power n minus 1. So 2x you get. Next d by dx of here d by dt of sin t, sin t. Why we have to take sin t? Because h of x you are taken as a t now. H of x you have taken as t. So it become, this function is a sin t now. So d by dt of sin t become what? Cos t. Okay. So this is nothing but dt by dx. This is this one dg by dt, dg by dt. So dg by dt into dt by dx, it gives what finally? df by dx. Okay. So it is a little bit for you confusing taking t and all those things. Directly you do this manner, so no one will decrease your mark. Okay. So this way doing is better always. So you just close this one. Sin, whatever inside present you take it as x, consider as x, and then you differentiate it, the outer function. Differentiation of sin x is cos x, but because it is not x, you need to consider its derivative into the d by dx of x square. D by dx of x square is 2x. So in a simple manner we can work it out. Here you need to multiply cos t into 2x. T means again x square. So you get same value, 2x into cos of x square, right? So that's why for the chain rule I used to prefer this formula all the time. D by dx of f of g of x is equal to d by dx of f of g of x. Chain rule in another way also we can write like this. D by dx of f of g of x is equal to f dash of g of x, f dash of g of x into g dash of x. Okay. I always prefer this formula for applying the derivative of composite functions, right? So only the first outer function we differentiate it, the inner function we keep as it is, into the derivative of g of x we consider, right? This process will continue on till you get x, okay, right? This is very easy to work it out. It's very easy to work it out by using this. Okay, so I prefer this formula to apply in the problems, right? So we'll work it out few more problems to understand in a better way. Differentiate the following functions. differentiate the following functions with respect to x. With respect to x. So, some 2-3 problems we write here. Sine of x square plus 5, cos of sin x, secant of tan root x, two times of square root of cot x square cos root x. Okay. To understand better this chain rule, we will work it out these 5 problems. See that first one. Solution to the first problem. So, d by dx of sine x square plus 5. D by dx of sine x square plus 5. So, by this chain rule formula, what I can do, first I apply for the outer function sine. Differentiation of sine is cos. Whatever may be present inside, you just take it as something like x and you work it out. Sine x, differentiation of sine x is cos x. So, cos x square plus 5. Is it really x? No. That is why you need to consider its derivative, d by dx of x square plus 5. So, cos of x square plus 5 into d by dx of x square, you all know it because you know the formula d by dx of x power n is n into x power n minus 1. So, d by dx of x square is 2x plus differentiation of 5 is 0, 2x plus 0. So, finally, you are getting 2x into cos x square plus 5. So, this is the answer for the first problem. The second problem, if we take it, d by dx of cos of sin x, So, again, d by dx of cos x, feel like x it is, whatever it is present here. D by dx of cos x is minus sin x. So, minus sine of sin x into, because it is not x now, you are assumed as x, that is it, into d by dx of sin x. So, what is d by dx of sin x? D by dx of sin x is cos x. So, this is the final answer, minus of sine into sin x, sine of sin x into cos x. If you see the third problem, secant tan root x. So, whatever may be, let it be inside, whatever it is present here. I just assume like x, because I know the formula, d by dx of secant x. What is d by dx of secant x? D by dx of secant x is secant x into tan x. Whatever you are assuming this is x, you need to differentiate it. That is it. So, d by dx of secant x is secant x into tan x, tan of tan root x, into, because it is not x, no, it is a derivative you need to consider. So, d by dx of tan root x, d by dx of tan root x. So, secant tan root x into tan of tan root x into, again you feel like this is x only, assume as x and start work it. D by dx of tan x is secant square x. So, secant square root x into, again because it is not x, no, we assumed as x, until you get x there you have to work d by dx of root x. So, what we are getting now, secant tan root x into tan of tan root x into secant square root x into d by dx of root x is 1 by 2 root x. So, this will be the derivative of d by dx of secant tan root x. Secant tan root x derivative is this. Now, we go for the problem number 4. See that problem number 4. D by dx of 2 times of square root of cot x square. Okay. So, the derivative of this function. 2 is a constant, you can write outside. So, 2 times of d by dx of square root of cot x square. Okay. So, we all know that d by dx of root x formula is 1 by 2 root x, right. Whatever is present inside, you assume like x, you just feel like x it is. And d by dx of root x is 1 by 2 root x. 2 root x is not x now, we are assuming as x we are doing, into d by dx of whatever you assumed as x, that you consider its derivative, d by dx of cot x square. So, what is d by dx of cot x? Let it be whatever it is present inside, you assume as x. Differentiation of cot x is minus cosecant square x. So, here this 2 get cancelled, 1 by square root of cot x square into the derivative of cot x is minus cosecant square x, but this is not x, you assume as x and we are doing, into d by dx of x square. What is this d by dx of x square? D by dx of x square is 2x. D by dx of x square is 2x. So, minus cosecant square of x square divided by square root of cot x square into d by dx of x square is 2x. Okay, this is the answer for this. Okay, so write properly these brackets and all. It's a very important problem for 2 mark questions in PU board based on the chain rule. We used to get a problem based on this chain rule for 2 marks. Okay, so one more question is there. Last one, cos of root x. Cos of root x. See that problem also we do it. D by dx of cos of root x. So, I told you just feel like it is something x and you proceed it. D by dx of cos x is minus sin x. Minus sin x. Is it really x? No, it's not really x. So, we assume to work it out. So, its derivative you consider. D by dx of root x. D by dx of root x formula is minus sin root x into d by dx of root x is 1 by 2 root x. That's it. This is the answer for that. So, it's a problem based on this chain rule. Okay. And then we'll go for next the derivative of implicit functions. So, we'll see now the derivative of implicit functions. Implicit okay, what do you mean by implicit function? Okay, there are explicit functions, implicit functions, parametric functions. Totally 3 types of functions we are having. Okay, explicit function means y is equal to fx, completely in terms of x will be given. Okay, explicitly in terms of x is given. Such type of functions are called as explicit functions. Okay, so far we are working based on this, right? Explicit functions only we used to work. Now, implicit function means they won't give like y in terms of x, they will give in terms of a relation f of x y is equal to 0. F of x y is equal to 0. Okay, they will give by their relation, the 2 variable relation, they will give it to you. F of x comma y is equal to 0. For example, like this, x square minus 2xy plus or minus 2y plus something y square is equal to 0. Okay, they won't give in a exclusive manner the y in terms of x. They will give by their relation like this, x square minus 2xy minus 2y plus y square equal to 0. Or otherwise something like sin xy, okay, sin xy plus xy minus 2 is equal to 0, like that. Okay. So, they are not giving y in terms of x in a straight away, they are giving by a relation. That means the relation between the x and y, they will give it here. Okay. F of xy is equal to 0 format, they will give. Those type of functions are called implicit functions. Parametric functions is different, I will tell it to you afterwards. This is the implicit functions. This type of functions, they are called implicit functions. They won't give y in terms of x explicitly, but by a relation they will give it to you, right. So, we will see some problems based on this. Here nothing new we are going to study. So, in implicit functions they will give the function like this, f of xy is equal to 0. Okay. Now, we will see some problems. Find dy by dx. Find dy by dx for the following. Find dy by dx for the following. The first problem, 2x plus 3y, 2x plus 3y is equal to sin x. Find dy by dx for the following. Okay. So, first problem, 2x plus 3y is equal to sin x. They have given like this. We need to find dy by dx for this. What do we do? This given thing, 2x plus 3y is equal to sin x. Just differentiating with respect to x on both the sides. We won't write again y in terms of x, all those things. Just differentiate with respect to x on both the sides. That means d by dx of 2x plus 3y is equal to d by dx of sin x. By the algebra of derivatives, what you can do? D by dx of 2x plus d by dx of 3y is equal to d by dx of sin x. Here d by dx of 2x, 2 is a constant, 2 we just keep it outside. D by dx of x, what do you get? 1 it is, right? Plus d by dx of 3y, 3 is a constant, we can write it outside, 3 into d by dx of y is dy by dx is equal to d by dx of sin x is cos x. So, what we are getting? 2 plus 3 dy by dx is equal to cos x. That means therefore, what is dy by dx now? Take this 2 to the other side, cos x minus 2, this into 3 become divided by 3. So, dy by dx is cos x minus 2 by 3 we are getting. Okay. We will see another problem. Xy plus y square is equal to tan x plus y. We need to find dy by dx for this. What do we do? Again same thing, differentiate with respect to x on both the sides. What happens? D by dx of xy plus d by dx of y square is equal to d by dx of tan x plus d by dx of y. Okay. So, d by dx of xy, what we can write? X into dy by dx plus y into differentiation of x is 1. We applied the product rule we applied the product rule. X into dy by dx plus y into d by dx of x is 1, right, plus d by dx of y square, it is 2y into dy by dx is equal to, because differentiation of x square is 2x into, here why we are doing again, because it is not x, it is, we have d by dx of x square formula, but we are not having d by dx of y square, but we assume as x it is, d by dx of x square is 2x, because it is not x, its derivative you need to consider. Again chain rule is involved here also. Okay. So d by dx of tan x is secant square x plus dy by dx, right. So we will separate all the dy by dx terms, bring this dy by dx this side, x dy by dx plus 2y dy by dx minus dy by dx, and the term without dy by dx take it to the other side. So secant square x, here it is minus y. When dy by dx you take common, what happens? X plus 2y minus 1 is equal to secant square x minus y. Therefore, dy by dx, what we are getting? Secant square x minus y divided by x plus 2y minus 1. Okay. So secant square x minus y by x plus 2y minus 1. This is a dy by dx of this implicit function. Okay. So one more problem we do it. Sin square y plus cos xy equal to k. K is some constant. K is some fixed constant. This is sin square y plus cos xy is equal to k. Now what we do? Straight away we just differentiate with respect to x on both the sides. Differentiate with respect to x on both the sides. Okay. So we differentiate with respect to x on both the sides. So d by dx of sin square y plus d by dx of cos xy is equal to d by dx of k. Okay. So d by dx of sin square y. So that means we are not having straight away formula for this. We apply d by dx of x square. D by dx of x square is 2x, 2 into x. Is it really x? No. So its derivative you have to consider d by dx of sin y plus d by dx of cos x. It's outer function. I told you, no, outer function. Feel like whatever it is present inside x and then do it. D by dx of cos x minus sin x. Is it really x? No. It's xy. D by dx of xy you have to consider is equal to d by dx of constant. It is 0. Now 2 sin y into, again d by dx of sin x. D by dx of sin x we have formula. What is d by dx of sin x? Cos x. But is it really x? No. Its derivative you have to consider. So dy by dx, here minus sign is there, minus sin xy into, you have to apply product rule here. So x into first function into derivative of the second function, d by dx of y is dy by dx plus y into second function into derivative of the first function 1 is equal to 0. Now you separate the dy by dx terms. So 2 sin y cos y, we know the formula, it is sin 2y, right, from trigonometry, into dy by dx, here minus, multiply this x into sin xy dy by dx this minus sin xy into y is equal to 0. Now we separate the dy by dx terms here. Separate them, dy by dx terms together and the terms without dy by dx take it to the other side. See that? So what we get dy by dx when we take common, dy by dx when you take common, in the first term sin 2y we get, and in the second term minus x sin xy we get. And this minus sin xy into y, take it to the other side. So it become, the minus become plus now. So y sin xy. We just brought this term, this minus term to the other side. So it become plus sign. So now therefore dy by dx is what? What is dy by dx? Dy by dx is equal to y sin xy divided by sin 2y minus x sin xy. Okay, this will be the answer for this. Okay. Derivatives of implicit functions we saw, and now we see derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. So first one, we'll see, find the derivative of fx is equal to sine inverse x. We'll see. Okay. The derivative of sine inverse x, we need to find it out. See that? We take this sine inverse x as something y. Y is equal to sine inverse x. Y is equal to sine inverse x. Then by inverse function properties, what we can write is sine y is equal to x. Sine y is equal to x. Now I just differentiate with respect to x on both the sides. Differentiate with respect to x on both the sides. On both the sides. What happens then? D by dx of sine y is equal to d by dx of x. So we apply chain rule here. We are having d by dx of sine x formula. What is d by dx of sine x? It's cos x. D by dx of sine x is cos x. But here it is y, it is present. So that's why we can write dy by dx. It's a derivative you need to consider. So cos y into dy by dx is equal to dy by dx of x is 1. So what we are getting dy by dx? Dy by dx is equal to 1 by cos y. Dy by dx of dy by dx is 1 by cos y. So that means cos y should not be 0 because it is in the denominator. Cos y should not be 0. So cos y should not be 0. So that means y should not be minus pi by 2 plus pi by 2 like that. So y means what? Sine inverse x. Y means sine inverse x. Sine inverse x should not be minus pi by 2 or pi by 2. So that means x should not be minus 1 or plus 1. Okay. So we should keep it in mind because whenever something denominator comes, it should not be 0. If it is 0, it becomes undefined. That's the reason we always should be careful with the denominator. Denominator should not be 0. So cos y is not equal 0. That means y should not be minus pi by 2 and pi by 2. And not only minus pi by 2, pi by 2, it is all odd multiples of pi by 2. But just for the sake of convenience sake only I took two values. Sine inverse x, y means sine inverse x because we have taken y this is. Y is equal to sine inverse x. That's why sine inverse x should not be minus pi by 2 to pi by 2. When we get sine inverse minus pi by 2 and pi by 2, when x is minus 1 and plus 1. So that's why x should not be minus 1 and plus 1. Okay. So cos y, what I can write? Now dy by dx is equal to cos y, I can write square root of 1 minus sine square y I can write. 1 minus sine square y. So what is sine y from this? What is sine y? Sine y is x here. So 1 by square root of 1 minus x square with the condition x not equal to minus 1 and plus 1. So therefore d by dx of sine inverse x is equal to 1 by square root of 1 minus x square, where x is not equal to plus or minus 1. Okay? X is not equal to plus or minus 1. Similarly, we are going to find out the differentiation of cos inverse x, tan inverse x, okay, cosecant inverse x, cot inverse x and secant inverse x. Okay? So similarly, we can find out for the other things also. But I am not going to give the proof of all those things. We just write the list of the formulae, the derivative of sine inverse, cos inverse, okay, tan inverse, secant inverse, cosecant inverse, cot inverse. So d by dx of sine inverse x is equal to 1 by square root of 1 minus x square. D by dx of cos inverse x is equal to minus 1 by square root of 1 minus x square. D by dx of tan inverse x is equal to 1 by 1 plus x square. D by dx of cot inverse x is equal to minus 1 by 1 plus x square. And d by dx of secant inverse x is equal to 1 by x into square root of x square minus 1. D by dx of cosecant inverse x is equal to minus 1 by x into square root of x square minus 1. Okay? So minus 1 by x into square root of x square minus 1. So where and all means its domains also is very important for us. Okay? So x cannot be plus or minus 1 here in this place whenever you are having like this. X cannot be plus or minus 1. So if I see that the domain of this f dash of x also is very important, minus 1 to plus 1. This is also minus 1 to plus 1. Here entire real number system. Here r minus of closed interval minus 1 to 1. Here also r minus closed interval minus 1 to plus 1. Okay. So these are the formulae you must remember to solve the derivatives of inverse trigonometric functions. We just solve some two simple problems and then we will stop this session. So we just take y is equal to find dy by dx. Find dy by dx for the function y is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square with the condition 1 by root 3 minus 1 by root 3 is less than x less than 1 by root 3. Okay. So we will find out dy by dx for this following function. See that y is equal to tan inverse of 3x minus x cube by 1 minus 3x square. So whenever you are getting inverse trigonometric function means first whether it is possible to simplify or not, you check whether it is possible to simplify or not. When you have good command on trigonometry, then what happens? You can simplify this function and so that we can differentiate it very easily. Now what I do is I take x is equal to tan theta here. Okay. Then what happens here? Tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. It is a formula of tan 3 theta. Formula of tan 3 theta. So now tan inverse of tan theta is theta if theta belongs to minus pi by 2 to pi by 2. That's why they have given one condition in this place. Minus 1 by root 3 is less than x less than 1 by root 3. X is tan theta. X is tan theta we have taken. So then theta present where? Theta present where? Theta present from minus pi by 6 to plus pi by 6. When tan theta is lie from minus 1 by root 2 to 1 by root 3, then theta lies from minus pi by 6 to pi by 6. Then you multiply with 3 throughout. When you multiply with 3 throughout, what happens? Minus pi by 2 is less than 3 theta is less than pi by 2. So we have the formula tan inverse of tan theta is theta if theta belongs to open interval minus pi by 2 to plus pi by 2. So 3 theta is present from minus 90 to plus 90. That's why what we can write, tan inverse of tan 3 theta is 3 theta we can write. 3 times of, what is theta from here? What is theta from here? Tan inverse x. So that means you are able to simplify the given function and it turns to a simple format y is equal to 3 tan inverse x. Okay. So you need to write this condition on right side every time, whatever the condition they have given it to you. And this is the formula we used. Now y is equal to 3 tan inverse x. Now we differentiate on both sides. In a single step we get the answer. Differentiate with respect to x on both the sides. Now what happens? So d by dx of y is equal to 3 is a constant anyway, 3 into d by dx of tan inverse x. So you are getting dy by dx is equal to 3 into d by dx of tan inverse x is 1 by 1 plus x square. This is the answer for that. 3 by 1 plus x square. Okay, so we'll do one more problem based on this. Y is equal to sine inverse of 1 minus x square by 1 plus x square. 1 minus x square by 1 plus x square, 0 less than x less than 1. 0 less than x less than 1. Like this the problem is given it to you. Given function y is equal to sine inverse of 1 minus x square by 1 plus x square. We take x is equal to tan theta. Then what happens here? Sine inverse of 1 minus tan square theta by 1 plus tan square theta. This is a formula of cos 2 theta. Okay, it's a formula of cos 2 theta. So this one you can convert it as sine inverse of sine pi by 2 minus 2 theta, because sine 90 minus theta is cos theta. Okay, so when you have good command on trigonometry, know all these things, what to substitute and how to simplify, you will come to know, right? Now pi by 2 minus 2 theta present within the range of the principal domain of sine or not, that you have to check it now. For that reason only they have given the condition here, 0 less than x less than 1. So we taken x as tan theta, right? We have taken x as tan theta. So theta lies from where to where? 0 to pi by 4. Theta lies from 0 to pi by 4. Multiply with minus 2 throughout now. Multiply with minus 2. Okay. When you multiply with minus 2, inequality changes. Whenever you multiply with something negative, the inequality changes. Suppose you see that 2 is less than 3. When you multiply with minus, what happens? It will become greater than, right? When you multiply with minus, inequality changes. So minus 2 into 0, 0, greater than minus 2 theta is greater than minus 2 into pi by 4. Minus 2 into pi by 4. So, minus pi by 2. Okay. And then add pi by 2 for this entire thing, because we are looking for pi by 2 minus 2 theta present where. So, add pi by 2 now. 0 plus pi by 2 greater than pi by 2 minus 2 theta greater than pi by 2 minus pi by 2. Okay. We are adding pi by 2 throughout. Okay. So, what we are getting, pi by 2 is greater than pi by 2 minus 2 theta is greater than 0, or otherwise the same thing you can write in other manner from that side. 0 is less than pi by 2 minus 2 theta is less than pi by 2. 0 to pi by 2 it is present. That means we have formula sine inverse of sine theta is theta if theta belongs to open interval minus pi by 2 to pi by 2. Okay, this is the formula we are having. Sorry, this is closed interval. We are having, okay, formula like this. Sine inverse of sine theta is theta if theta belongs to closed interval minus pi by 2 to pi by 2. So, it is present within the principal domain of sine. So, that is why according to that formula I can write pi by 2 minus 2 theta is. So, what is theta from here? Again, theta means tan inverse x from here. So, y is equal to pi by 2 minus 2 tan inverse x. See that big function whatever you are having, it is simplified. Now, you differentiate it, easily we get the answer. So, differentiate with respect to x on both the sides, x on both the sides. So, d by dx of y is equal to d by dx of pi by 2 minus 2 is a constant, 2 times of d by dx of tan inverse x. So, this become dy by dx, d by dx of constant is 0 minus 2 into d by dx of tan inverse x is 1 by 1 plus x square. So, the final answer is what now? It is equal to minus 2 by 1 plus x square. Minus 2 by 1 plus x square we are getting, right. So, in this manner we can work it out the derivatives of inverse trigonometric functions. Okay. So, we will see that in the coming session. Few more problems also we will work it out. Thank you.